Hello, this is Eric Clausen, and I'll be discussing in this presentation the Spearfish Creek Rapid Creek Drainage Divide, which crosses some of the highest areas in the Black Hills, which are located in South Dakota. And this drainage divide is anomalous evidence. And by anomalous evidence, I mean it's evidence that the accepted geology paradigm, which is how geologists explain how features formed on the Earth's surface, does not give a good explanation of how this drainage divide formed or of some of the features that we're going to be looking at. And I'm going to be using topographic maps primarily to illustrate the drainage divide. But that's what the subject of the presentation is. Let's move into looking at where this drainage divide is. And here's a map of the Black Hills area. You can see the Black Hills cross the Wyoming South Dakota border. This is the border between South Dakota and Wyoming here, and then the southeast corner of Montana is up here. This map shows the Black Hills uplifted areas in green, and generally the Black Hills are a domal uplift, which stand roughly where the surface of the higher Black Hills in the area that we're going to be looking at is at least 3,000 feet higher than the gray areas, which you can see completely surround the Black Hills. So what we're going to be looking at is we're going to be looking at an area up here in the western Black Hills near the South Dakota-Wyoming border. And where the drainage divide between north-oriented Spearfish Creek here shown with the S and southeast-oriented Rapid Creek shown with the R is located. Now, you'll notice that Spearfish Creek flows in a north direction here. It joins the Redwater River, and together they join the southeast-oriented Belle Fourche River here, shown with a B. The Belle Fourche River is kind of interesting because it begins as a northeast-oriented river, gets up here to the northwest end of the Black Hills area, and then it turns in a southeast direction to join the Cheyenne River, which is shown with C's here. Now, Rapid Creek, as you can see here, starts out almost right at the Spearfish Creek uh, location, and then it flows in a southeast direction, comes down off the high Black Hills, just as Spearfish Creek does, and it joins the northeast-oriented Cheyenne River. And the Cheyenne River, like the Belle Fourche River, is kind of it starts out here in the west of the Black Hills, flows in a southeast direction, and then turns in a northeast direction to join the Belle Fourche River, and then the flow further, and eventually it'll join the south-oriented Missouri River. Now, both Spearfish Creek and Rapid Creek are what we would call barbed tributaries in that they do not flow in the same direction as the streams that they flow. And this is often considered to be evidence that there's some kind of stream capture going on here, but the details of those stream captures have never been explained real well, at least in most of the geologic literature. I've tried to explain it in some of my publications, but most other geologists avoid discussing it because it requires um, departures from the accepted geology paradigm. But anyways, this is the area that we're looking at, and I want to again emphasize that we're looking at the highest areas in the Black Hills, or Western Black Hills. There are some higher areas in the Eastern Black Hills, but they're not on major drainage divides like this is here. And so that's the area that we're looking at. And I'm going to start out at the north end of the Spearfish Creek Rapid Creek drainage divide. I've shown on this topographic map, which has a 20-foot contour interval, and that'll be true of all the maps that I'm showing you. And that the orange lines here are showing the major drainage divides, and the Spearfish Creek Rapid Creek drainage divide starts here. To the north here is the Spearfish Creek Whitewood Creek drainage divide. Whitewood Creek, like Spearfish Creek, is a north-oriented stream which flows to the Belle Fourche River like Spearfish Creek, but we won't be discussing Whitewood Creek. Now, the drainage divide at this point is about 6,500 feet when you're on the higher areas along the drainage divide. But there are a number of valleys that are crossing that drainage divide, and that's going to be the main emphasis of my talk today. The valley here at number one, it connects the northwest-oriented East Spearfish Creek Valley with the southeast-oriented North Fork Rapid Creek Valley. And this is a valley that's almost 300 feet deep here. It's an erosional valley, which indicates that it was formed at a time when water flowed across what is now the drainage divide. And remember, we're here in some of the highest areas in the Black Hills. So where did the water come from? And I'm going to be arguing in this discussion that the water probably came from the northwest, but there's no place today to the northwest where the water could have come from. In fact, all areas to the northwest of the Black Hills are at least 3,000 feet lower than the area that we're looking at here. Now, number two here is not across the drainage divide, the Spearfish Creek Rapid Creek drainage divide. It's across two tributaries to Spearfish Creek, but it's a valley that's about 150 feet deep, and it's also an erosional valley. And if you look at these valleys, the arrangement of these valleys, it looks like if we were dealing with southeast-oriented water coming here, that the water would have diverged into two different channels here, maybe even three different channels here, multiple channels, and then the channels come together here. This is what we call an anastomosing drainage system, and this is all the characteristics here of an anastomosing drainage system. And anastomosing drainage systems, large scale like this, are what you would expect to form if there was a huge flood flowing across the region. But the question is, where did the water come from? There's no water source today that's visible. And so we're going to be dealing with this question here. Now, if we come to number three here, we've got another erosional valley across the drainage divide. This one is about 130 feet deep, and number four here is another one. And again, these can all be considered parts of a large anastomosing drainage system, which consists of diverging and converging valleys, which would have been formed during a major flood flowing across this region. But again, I want to emphasize there is no source for the water. Now, if we continue in a southwest direction along the Spearfish Creek Rapid Creek drainage divide, here's number four that we saw in the last slide. But if we continue here in a southwest direction, we come to number five, which is about 120 feet deep, another erosional valley. Number six is somewhat shallower. It's only about 80 feet deep. Number seven is about 90 feet deep. Number eight is about 110 feet, and number nine is much shallower. It's only about 30 feet deep. But these are all, again, valleys that are suggesting that we had a huge anastomosing channel complex crossing what is now the highest areas in the Western Black Hills. And I want to emphasize Tilson Creek here is Rapid Creek tributary. So we're still in the Rapid Creek drainage basin here, even though it's labeled Tilson Creek. Uh, but one of the things that's interesting is that the high points along the drainage divide are getting higher as we go to the southwest. And we're the highest point here is about 200 feet higher than the highest point in the previous slide. Let's continue to the southwest. Here is the drainage divide coming down here. This is the drainage divide between Tilson Creek, which flows to the North Fork of Rapid Creek, and the South Fork of Rapid Creek. And we'll notice that there's a deep valley here that's about 200 feet deep between these two here. But if we look at number 10 here, this is about 120 feet deep. Number 12 is a much shallower valley, only about 40 feet deep. But again, we've got more evidence of these anastomosing channels flowing across the drainage divide. Now, at the bottom here, where the drainage divide is crossing the bottom of this map section, we have Crook's Tower. And I want to mention Crook's Tower. You can see a picture of it here taken off it, where this is the highest point in the Western Black Hills. It's on the drainage divide. And as I mentioned, there are some higher points in the Eastern Black Hills, but they're not on a major drainage divide like Crook's Tower. And this is the highest point in the Western Black Hills. And yet we still have these anastomosing channels, evidence for these anastomosing channels crossing the drainage divide. Now, continuing to the southwestern end, Crook's Tower of the drainage divide. Crook's Tower is here. We still have number 13 is a valley. It's about 150 feet deep. Number 14 is shallower. It's only maybe 20, 40 feet deep. But we've still got more valleys crossing the drainage divide. And then if we look at some of the adjacent drainage divides, we've got more valleys here that are suggesting that the anastomosing channel complex was much more extensive than just across this drainage divide. So anyways, Cold Spring Creek here flows in a south direction to join the Cheyenne River, but it joins the Cheyenne River in the west, further to the west of where Rapid Creek does. And so we've got a major north-south drainage divide here, and we've got evidence that water flowed across it. Now, I'm going to I've kind of summarized here some of the evidence in terms of elevations that we're looking at, and I want to emphasize that these are the 14 numbered drainage divides that I showed you. Number 2 and number 11, if you remember, did not cross the Rapid Creek, the Spearfish Creek Rapid Creek drainage divide. Number 2 was within the Spearfish Creek drainage basin and was a valley. And number 11 was a valley within the Rapid Creek drainage basin. But they were close to the drainage divide. And so what I'm showing you here is the approximate valley floor elevations. And you'll notice that as we proceed in a southwest direction, the floors of the valleys that are being crossed do rise as we go in a southwest direction. Now, if we look at the valley depths, I've shown you valley depths here in feet and also in meters. Um, and that they're kind of random, but they're the deepest one is right the first slide, the map that I showed you. But the others, there's some uh, good, uh, they're good sized erosional valleys. Something definitely eroded them. And then if we look at the ridge where and here I'm taking the highest point that's to the north of the valley that is numbered. And you'll notice that that the drainage divide today rises in a southwest direction. I interpret this to mean that probably at the time that the drainage divide was formed, that there were huge floods flowing across what was a rising Black Hills area. For a time, the floods were eroding the Black Hills down, but the Black Hills continued to rise faster than the floodwaters could erode the top of the Black Hills, and that eventually the Black Hills, the floodwaters were forced to flow around the Black Hills and not over the Black Hills. And so what we're seeing here is that the drainage divide was created when the Black Hills uplift proceeded faster than the floodwaters could erode the region down. And that and that the difference in elevation here is probably not a difference, is probably a difference that was created by uplift that has occurred since the drainage divide was formed. Now, I want to emphasize there are no higher areas surrounding this region where a large flood could have originated. What I've shown you is evidence for a huge flood that crossed the highest Black Hills region. Uh, that and I think that the best interpretation for the valleys that I've shown you is that the valleys were all eroded during the same event, which eroded the Spearfish Creek headwaters valleys and also the Rapid Creek headwaters valley. I think the elevations along the drainage divide uh, they do range in elevation from about 6,440 feet at the northeast end to 7,137 feet near the southwest end of the drainage divide. And I think that difference in elevation is probably the result of Black Hills uplift that has occurred since the drainage divide was formed. And the same thing with the valley floor elevations. And I think the only explanation that can explain this evidence is that the Black Hills had not been uplifted or were in the process of being uplifted at the time that massive southeast oriented floods flowed across the region, and that uh, the uplift forced the floodwaters to eventually flow around the region. That's what created the drainage divide, and that the uplift has continued following the drainage divide formation. And we're seeing the evidence for the massive flood. Now, the problem with this that geologists have is there's no water source. That I don't think anyone would argue with the evidence that I've shown you. It's very clear cut on the maps. It's clear cut if you go up there and you look at the region. Uh, but the problem is that this drainage divide, as I told you, is standing at least 3,000 feet higher than all the areas surrounding the Black Hills. So there's no place that the southeast oriented floods could have come from. And if you want to argue, the floods could have flowed in a northwest direction, and there's even a bigger problem with where the water came from if you're looking at a northwest direction. But I prefer the southeast-oriented interpretation, and that there is a flood source that could account for the kind of flood that we're talking about here. But the timing of that flood source doesn't fit with the geologic history that is usually described for the region. And that flood source would be a melting continental ice sheet. Now, the Black Hills were never glaciated, but they're close enough to the margin of where a continental ice sheet would have been that it's possible that huge ice marginal floods could have flowed in a southeast direction around through the region. The trouble is that the Black Hills are usually thought by geologists to have been uplifted before continental ice sheets existed. So there's a timing problem here that geologists have. And for that reason, geologists don't want to discuss, or they try to avoid discussing the evidence that I've shown you here. Now, if you want more information about this, to the best of my knowledge, I'm the only geologist who has actively published reports in which the origin of the Spearfish Creek Rapid Creek drainage divide is discussed and the valleys across it. And my most detailed discussion is in my paper, which was published in 2018 in the Journal of Geography and Geology, number 10, number 1. And the title of that paper is Topographic Map Analysis of High Elevation Black Hills through Valleys, Linking Spearfish and Rapid Creek Headwaters Valleys in Lawrence County, South Dakota. It's found on pages 8 through 21 of that journal, and that journal is an open access journal, so there's no charge to access the articles in it. And I just want to conclude by saying that the project that led me to the Black Hills evidence is discussed in my book, The Topographic Map Mystery, Geology's Unrecognized Paradigm Problem, Revised Edition. And the book is available at some academic and public libraries. It can also be purchased from online booksellers.